Hey everyone, and welcome to Mr. Ahmed's Math 20 screencasts. Today we are starting up Chapter 2, and we're going to pretty much be talking about graphs this entire chapter. We're going to start off with the very first topic, which is broken line graphs. So that's 2.1, broken line graphs. A broken line graph pretty much looks like this. Okay, so you've got a bunch of dots on your graph, and they're linked by a broken line. Okay. So it really just shows information by plotting values and joining them with line segments. Okay. Now, when you're asked to draw a broken line graph, there are a few things that you need to know. So first of all, you've got to figure out a title for your graph. Okay. So depending on the situation, you will be asked to make an appropriate title for the graph. Okay. You'll also be asked to label the horizontal and the vertical axes. Okay. A reminder from the last few screencasts that the independent variable is the variable or the values that you would put on the x-axis. So your independent variable goes on the x-axis, which is the horizontal axis. Now your dependent variable, that's the variable that depends upon the independent variable, that one would go on the y-axis. Okay, so that's just a reminder that when you are graphing, you do want to try to kind of follow those rules. You're going to have a title that kind of describes your graph accurately, and then you also want to have your independent variable on the horizontal axis and your dependent variable on the vertical axis. Okay, so taking a look at example 1, average monthly snowfall in Regina, Saskatchewan. So that's a pretty good title. Looking at the title, you have to be able to, the title should pretty much explain what you're looking at in terms of the graph. Okay, so it has to be make a good summary of what you're looking at here. Okay, so average monthly snowfall in Regina, Saskatchewan. There's no doubt as to what we're about to look at here. Okay, so you can see the points, and then the month is the independent variable. The snowfall is the dependent variable, and the way if you're not too sure about that, just think of it as snowfall is the dependent variable because it depends upon the month. Okay, so the amount of snowfall that we get depends upon the month and the year, and not vice versa. The month and the year does not depend upon the snowfall, the amount of snowfall that you get, right? So it's not because you got, I don't know, what is that, 3? It's not because you got 3 centimeters of snow that it absolutely has to be May. Okay, so just the snowfall depends upon the month and not back and forth. The month does not depend on the amount of snowfall that you get. Okay, so doing a few of these questions, what month has the highest average snowfall? So once again, this is really just kind of taking a look at the graph and being able to answer these questions. So which month has the highest average snowfall? So which one of these points is the highest? It looks to me like December is the highest, and it's sitting at about 21 centimeters. Okay, and how much snow fell that month? Well, there you go, 21 centimeters. During what 3 months is there no snowfall in Regina? Well, you're looking for the 3 months where you've got 0 centimeters of snow, and that's June, July, and August. And during what month is the average snowfall approximately twice as much as the average October snowfall? So taking a look at the October snowfall, you've got roughly 7 centimeters of snowfall. Okay, so October looks like it's got 7 centimeters of snowfall. So what we're doing is we're looking for a month that has twice as much as 7 centimeters. So twice as much as 7 centimeters is 14 centimeters. So we're looking for a month that's sitting at about 14 centimeters on this line right here. It looks like February is sitting on that, and November, although November looks like it's slightly below 14 centimeters, but it looks like November and February, although February would be the better answer here. So February does look like it would be the month that has approximately twice as much snowfall as October. Okay, so again, these examples, I'm just kind of talking you guys through them. They are already ready and answered in your workbook there. Okay, so we've got a few build your skills questions here that you want to try your hand at. And on to example 2. So Jacob owns a small appliance repair company. He tracked the company's net profits over a 10-year period. He's examining the data to see if there's a trend and to decide if he can increase the salaries of his employees. Graph the data on a broken line graph. So to properly graph a broken line graph, again, you'd need a good title. You could probably say Jacob's company's net profit from 2000 to 2009. So that would be a pretty good title. Now you'd have to decide what is your independent variable. A reminder that your independent variable goes on the x-axis or the horizontal axis, and your dependent variable goes on the y-axis. Okay, so here looking at this, your dependent variable would probably be the profit, because the profit fluctuates or changes, increases or decreases as a result of the year. Okay, so maybe here in 2009, looks like he made $65,000, right? Because this is profit in thousands of dollars. Looks like he made $65,000 here, and that would be a result of the year 2009 probably being a really good year. Okay, so the independent variable would be the year. So this is what you'd want to try to get on your x-axis. And the profit would be your y-axis. That would be your dependent variable. This would be kind of the responding variable. Okay. The dependent variable, you can also think of it as the thing that you measure. Okay. So just a quick reminder back up here in our first graph. There you go. The dependent variable was the snowfall. That's kind of what you measure. Okay. That's like the data you're collecting. That data that you're collecting is pretty much what goes on the y-axis. Okay. So same thing down here as well. Okay, so here your net profit is kind of the data you're collecting. Okay, so there you go. There's the title. You put the year in the independent variable, which is on the x-axis. The dependent variable goes on the y-axis. Okay, and they decided to go up by increments of 5, so 5, 10, 15, 20, 25, 30. So this is really kind of your call to make. Just make sure that you are going up by nice even increments. So you're not going up by, for example, 3, and then 10, and then like 16, and then like randomly 36. And so you do want to increase by same amounts of increments. Okay. Is there a general trend in the data? If so, what is it? Are there any exceptions to the trend? Well, it looks like they were making pretty good profit. They kept kind of increasing up until 2004. Looks like they dipped slightly in 2005, kind of stabilized in 2006. But then they had a pretty big dip from about 43. That was in 2006. So up here, yeah, 42. So they dipped down from 42 to 20. From 42 to 20 from 2006 to 2007. So it does look like there was a pretty big dip from which they recovered rather quickly and actually are now making much more profit in 2008, and it keeps going in 2009. So that's kind of what you want to say for that question. Is there a general trend in the data, and what is it? Are there any exceptions? You pretty much just want to say, well, it looks like it's going on. It looks like everything's going fine until about 2006 to 2007. There's a pretty big dip in 2007. Okay. So we've got a few more build your skills questions. We're moving on to interpolating and extrapolating. Okay. So interpolating is pretty much when you've got data on a graph or on a broken line graph, and you're trying to figure out a value that would fall on that graph, but a value that would be between two values on the graph. Okay, that's what interpolating means. You're trying to figure out a value that's between two values on the graph. Now, extrapolating a value, that means that on your graph, you'd be trying to like if you've got a graph that goes up to, I don't know, let's say you've got data that goes up to like Wednesday or something. Okay, so let's talk about like in terms of temperature or something. And it looks like on Monday, Tuesday, Wednesday, there's a regular kind of everything. The temperature's been going up steadily. And let's say you don't have data for Thursday, but if the temperature was going up steadily, then you could probably extrapolate a value for the temperature on Thursday. That means that you'd kind of extend the value beyond the data that you have. Okay, so you predict a value from beyond the data that you've got. Okay, so just to give you an example, let's go back to interpolate. Okay, so to give you an example of interpolate, let's say someone was measuring temperature decreases throughout a week. Okay, so let's say on Monday the temperature was 25 degrees Celsius. On Tuesday it was 20 degrees Celsius. On Wednesday we don't know what the temperature was. The guy kind of forgot to, I don't know, they forgot to measure the temperature. On Thursday the temperature is 10 degrees Celsius, and then on Friday it's 5 degrees Celsius. So as you can see, well, see, but you know, just hear what I'm describing. We went from 20 degrees Celsius down to, so 20 on Monday, 15 on Tuesday. Don't know what happened on Wednesday. 10 on Thursday, and then 5 on Friday. Okay, so that means that you could pretty much interpolate a value for Wednesday. So if we started off at 25 degrees Celsius on Monday, and then on Tuesday we are now at 20 degrees Celsius, then maybe on Wednesday it was at 15 degrees Celsius, where the temperature kept dropping by 5 degrees Celsius every day, right? So that way I just interpolated a temperature for Wednesday by saying that if Monday was 25, Tuesday was 20, then Wednesday would be 15, and then Thursday is 10, and Friday is 5. Okay, so that's interpolating. Extrapolating a value could have been, for example, extending that little line, because you know how we stopped at Friday, and Friday was 5 degrees Celsius? Extrapolating, you could pretty much say, well, what was the temperature on Saturday? Well, if the entire week we've been steadily dropping by 5 degrees Celsius every day, then I think it would be okay to say that, oh, well, on Saturday, then it's probably, 0 degrees Celsius. Okay, so you just extrapolated a value based on the trend, the downward trend, that the fact that every day the temperature dropped by 5 degrees Celsius. So you just extrapolated a temperature value for Saturday. That's what interpolating means, and that's what extrapolating means. Okay. So here we've got the growth rate of a bean plant that David planted in his vegetable garden. And so we're talking in terms of weeks and height. Okay. And then also just, you've probably noticed by now that usually the independent variable will be time. Okay, so if you've ever got time, that's pretty much always the independent variable, and it'll always be down here on the x-axis. Okay, so here we had weeks, and then before we had months, and then before we also had years. Okay, so anything that deals with time is usually on your x-axis. Okay, so David forgot to record the height of the bean plant in week 4. Use the graph to interpolate the height of the plant that week. Well, looks like he had a value for week 3, which was 15. And he had a value for week 5, which looks like it's 29. So the value between these two at week 4 looks like it's about 22. Looks like at week 4 the plant was roughly at 22 centimeters. Okay, so it looks like it was right about here, and that would be 22 centimeters. Okay, what might the height of the plant be in week 12? Now here in A we just interpolated. This question, B, is asking us to extrapolate. Okay, so we can see that on week 9, 10, and 11, the plant doesn't seem to be growing much anymore. Looks to me like we're about 38 centimeters height. So I think it'd be safe to say that on week 12, assuming that the plant kind of stopped growing, that on week 12 that would also be like 38 centimeters or maybe 39 centimeters in case the plant decided to grow slightly. Okay, so that's extrapolating. And then finally C, write a statement describing trends in the bean plant's growth rate from week 0 to week 11. If you're trying to describe this trend, you can pretty much say, well, from week 0 to week 2, the plant seems to grow rather steadily and somewhat slowly, not too bad though. But then from week 2 to 4, no, 2 to 5, there we go, so from week 2 to 5, the plant seems to grow at a very steep rate, at a very high rate. Right? So the steeper the line, the bigger the slope, the higher the rate of change. So it looks to me like the plant had like a growth spurt or whatever. Then from week 5 to week 8, looks like it's roughly growing at the same rate, slowed down a little bit. From week 8 to 9, there's another little tiny growth spurt, but then afterwards, from week 9 and onwards, it doesn't look like the plant is growing much anymore. Week 10, yeah, it did grow a little bit here, but not much is happening over here. It looks like it's pretty much reached adult size. Okay. So that's kind of those statements that you can make based on that kind of graph. So again, a reminder that you do have a nice title. And then down here you've got nice increments of weeks, like 0, 1, 2, 3, 4, 5 weeks, so it goes up by increments of 1. And then here you're going up by increments of 10. So that's kind of what you're aiming for. You don't want to have weird, funky, I decided here to go from 0 to 2, and then from here I went from week 2 to 10, and then from here I'm going to go from week 10 to 11, and then 12, and then week 20, so you want to make sure you have even, like, same amount of increments. You don't want to change the increments, okay? That's kind of the point I'm trying to get across here. Okay, so we've got a few build your skills questions. Example 4, Brett is a real estate agent, is comparing the average listed prices for houses in Vancouver to those in Regina from 2006 to 2010. This right here would be your title on your broken line graph. As we already said, the year, anything that deals with time, that's usually your independent variable and will be on the x-axis. And the prices that fluctuate, or are the dependent variable because they depend on the year, those are your dependent variables and would be on the y-axis. Now, you do see that you've got two sets of data here. You got a set of data for Regina and a set of data for Vancouver, and it's quite all right to have two lines on a broken line graph. Okay, so that's just fine. There's no problem with that. So to display the information on a broken line graph, again, you want to have a nice title, the correct independent variable down here, the correct dependent variable up here, and you also want to use a good scale on the side here. And well, here it's just going to be your year, but make sure you use a good scale over here. Okay, so again, you want to jump by same amount of increments each time. What conclusions can you draw from the table about house prices in the two cities? Well, it looks to me like in Regina, from 2006 to 2008, there was a steady increase in house prices, whereas in Vancouver, that pretty much stayed the same. And then 2008 to 2010, Regina stayed pretty much the same, whereas Vancouver experienced an increase in house prices. So that's kind of what you're aiming for. What can you tell from the graph more readily than from the table? Well, you can see that over here there was an increase, and over here there wasn't. And that in Regina, when there wasn't an increase, in Vancouver there was. Okay, so that's kind of what you can see here. Your workbook says that you can tell that the prices in Regina increased more rapidly than in Vancouver from 2006 to 2008. So really just saying that there's an increase over here. But then that afterwards in Vancouver, the house prices rose. So just things that you can easily tell looking at the graph that you might not necessarily be able to tell just looking at this. Okay. So a few more build your skills questions that you guys ought to try out. And then finally, working with misleading graphs. Okay, so the scale and the size of a graph can influence the way you interpret the data. By changing the scale, so on the left-hand side here, on an axis, or changing the starting point of an axis, you can absolutely change how a viewer interprets the graph. So, looking at this graph over here, the graph below indicates the approximate cost of sheet metal per ton over a period of time. Looking at this, my initial reaction is, wow, there was a huge fluctuation in sheet metal each year in terms of price. Okay. So it looks to me like price here is almost like 3 times as much as it was down here, and oh god, it's back down to being really cheap again, and that's kind of what it looks like. But that is actually misleading in that that's not actually the fact. What happened here, this little squiggly line, is that the guy, well, not the guy, but the person who graphed this decided to go from 0 to 500 in one jump. Okay, so this little broken line right here, just kind of not broken line, but zigzaggy line. All that shows is just that it was a huge jump from 0 to 500, okay? Now, that huge jump right here is what makes our graph so misleading, okay? So what does it appear has happened to the price of sheet metal? I answered that one. Looks like it was fluctuating a lot. What are the scale and starting point of the vertical axis? Well, the scale looks like it's going up by 50 each time, okay? But the starting point looks like it's at 500, and that's what's throwing this entire graph off, okay? Redraw the graph starting the vertical axis at 0 and using the same scale. What does this new graph show about the fluctuation in prices? Well, here's the new graph, and now, having started at 0 and going up by 150, 300, so we're going up by jumps of 150. Looking at this, you're no longer under the impression that those prices were fluctuating as much as they seem to be fluctuating over here. Remember when I said wow, this looks like it's pretty low, and then this is like 3 times as expensive as it was in here. Well, that's not the case. Here's what's actually been happening. Okay, so that's how a graph can be misleading, is by starting your the starting point of the vertical axis would be perhaps too high and therefore mislead the person looking at the graph. Okay, so you do want to make sure that you do start off your graph at 0 and to do nice even jumps just to avoid any potential confusion with or avoid your graph being misleading. Okay. Um, but otherwise, that is pretty much it for this little topic. You've got more build your skills questions, and you've got your practice your new skills questions. So again, do check out School Zone. I mean, you'll have checked out School Zone because you're watching this video, but on School Zone you'll also find the questions that you're supposed to be working on for this subtopic, as well as the answer key. That way you can just make sure that you're getting it all right. Anyways, that's pretty much it. So stay tuned for chapter 2.2.